Concept: Bohr's model of hydrogen atom and its limitations. Arrange an electric discharge tube filled with hydrogen gas, slit, prism, and a screen in a dark room. When the switch is on, hydrogen gas in the discharge tube gets excited and the light emitted is viewed through a grating and prism respectively, forming a diffraction pattern on the screen. Here, the pattern obtained on the screen represents the spectrum of hydrogen. The spectrum observed consists of 4 individual lines with well-defined wavelengths. Experiments have shown that the wavelengths of lines were characteristic of chemical element emitting the light. Bohr's model explains the atomic emission spectrum of hydrogen. While the electron of the atom remains in ground state, its energy is unchanged. When the atom absorbs one or more quanta of energy, the electron moves from the ground state orbit to an excited state orbit. Different orbits in which electrons revolve are known as energy levels. Energy levels are designated with variable n. The ground state is n is equal to 1. The first excited state is n is equal to 2, and so on. The energy that is gained by the atom is equal to the difference in energy between the two energy levels. Atom releases energy when the atom relaxes back to a lower energy state that is equal to the difference in the energy of two orbitals. You can see electron transition when electron jumps from third energy level to second level. It releases energy which corresponds to the energy of red light wave. Similarly, when the electron jumps from fourth to second shell, it releases green light. Fifth to second, it releases blue, and from sixth to second, it is violet. Based on the wavelengths of spectral lines, Bohr was able to calculate the energies that the hydrogen electron would have in each of its allowed energy level. Limitations of Bohr's model. It failed to explain spectrum of other atoms except hydrogen atom. It could not explain the binding of atoms into molecules. The Zeeman and Stark effect are not explained in this model.